an official website of the United States government. Ocean heat. The Global Ocean Monitoring and Observing Program conducts long-term ocean observations that help us better predict and prepare for the impacts of hotter seas, including rising coastlines, changing fisheries, coral bleaching, and more frequent storms. Visualization of global sea surface temperatures. Image credit, NOAA Climate Program Office. The global ocean is getting warmer. NOAA is dedicated to understanding how much and how fast the ocean will warm, and what the ripple effects will be. Measuring changes in ocean conditions, producing data sets and tools that are accessible for a range of users, and improving model projections are a few ways that we are empowering leaders and communities across the globe to make informed marine management decisions. Time series visualization of daily average sea surface temperature. Click image to expand. Use the slider to view the 2013 versus 2024 sea surface temperature anomalies. The colors indicate the temperature difference in degrees Celsius. Image credit, climateryanalyzer.org. Climate Change Institute, University of Maine. What happens in the ocean doesn't stay in the ocean. Increasing ocean temperatures affect people on land, atmospheric processes, glaciers and ice sheets, and living organisms everywhere. Ocean heat impacts our weather. The ocean and atmosphere exchange gases which affect things like how much heat or moisture the air can hold. This, in turn, influences weather across the globe. Warmer ocean waters are connected to changes in day-to-day weather, stronger storm events, like hurricanes, and influence longer-term climate events such as El Niño and La Niña. With the frequency of billion-dollar weather and climate events increasing, understanding the role of ocean heat in future storm projections is critical to protect communities and infrastructure. Ocean heat impacts our coastlines. Polar ice sheets may seem far away, but the response of these frozen masses to increasingly hotter ocean waters impacts us worldwide. As interactions between warming ocean waters and ice shelves, floating extensions of ice on land, drive increased rates of ice melt, more ice moves from land to the ocean and causes global sea level to rise. This sea level change impacts the nearly 40% of the U.S. population that lives in a coastal county, where onshore infrastructure loss and nuisance flooding are increasingly of concern. Melting glaciers and ice sheets are not the only contribution to sea level rise. As water molecules warm, they expand. This thermal expansion is another driver of sea level rise, and also plays a role in the frequency and severity of hurricanes and tropical storms. Image credit, Barbara Taylor NMFS/SWFSC/PRD. Image credit, Adamo Beza, WCR Protected Resources Division. Ocean heat impacts our ecosystems. From the surface to the seafloor, in the deep ocean and the coasts, marine organisms everywhere are impacted by warming ocean temperatures. Warming oceans are driving changes in the abundance of fish species, like Pacific salmon, while also impacting migration patterns of many different fish and mammal species, which coastal communities have relied on for generations. Shifting marine ecosystems in response to ocean heat not only affects economies. The U.S. commercial seafood industry is worth $6 billion, but also threatens cultural and spiritual ties to marine life as a means of subsistence. Microscopic marine life is also responding to warmer waters, and this causes ripple effects up the food chain. Elevated ocean temperatures are linked to overproduction of different species of saltwater algae, some of which are toxic. These harmful algal bloom, HABs, events have been reported offshore every coastal state, and the frequency of HABs are on the rise in places like Alaska, introducing serious threats to human health and marine economies. Excess heat is stored by the ocean. As the concentration of gases like carbon dioxide and methane in Earth's atmosphere continues to increase, predominantly as a result of human activities, so does the amount of solar energy, or heat, trapped by the Earth's climate system. Much like a greenhouse, the amount of heat that enters into the atmosphere is greater than what escapes back out into space, leading to an overall increase in temperatures. The global ocean absorbs up to 91% of the excess solar energy that cannot be reflected back into space. Climbing sea surface temperatures receive a lot of attention, but ocean heat does not only stay at the sea surface. Global ocean circulation slowly moves those warm water molecules from the surface to the deep ocean, where slow, but important, warming also takes place. While it takes about 1,000 years to move a parcel of water through the entire ocean, this means that greenhouse forcing is reflected at all depths of the ocean, just on different time scales. Why the ocean? It all comes down to two physical phenomena, albedo and specific heat capacity. Have you ever chosen to wear a light-colored shirt in the summer instead of a dark one, knowing it would keep you cooler? Dark objects, like your dark t-shirts and the ocean, have a low albedo, meaning they retain more heat than they reflect. Not only does ocean water have a low albedo, but it also covers over 70% of our planet, making it a natural storage space for excess heat. Sea ice, or frozen ocean water, is a natural, highly reflective, high albedo barrier against ocean heat absorption. However, the steady trend of decreasing Arctic sea ice exposes more ocean water and creates a feedback loop of increased warming. The ocean also requires significantly more energy, over 1000x more, to warm by 1 degree Celsius compared to the atmosphere. You can see this phenomenon, called specific heat capacity, at work the next time you're around a gas stove. When you put your hand above the flame, you feel the heat instantly because the air is warmed quickly. However, when you put on a pot of water to boil, the water takes some time before it warms up. So, what does this all mean? Any measurable change of global ocean temperatures, even a fraction of a degree, represents the absorption of a substantial amount of energy over a relatively short amount of time. Between 1993 and 2022, the amount of heat energy absorbed by the ocean was more than 800 times the total electricity consumed by the United States in just 2022, the year with the highest energy use recorded. Understanding the impacts and drivers of these changes, and improving our predictions of future change, are fundamental in building a climate-ready nation. Learn more about how NOAA is leading these efforts through sustained observing and modeling of our global ocean below. How NOAA is monitoring and predicting impacts of ocean heat. The lack of long-term measurements of the global ocean and changes in the observing system over time makes documenting and understanding change in the oceans a difficult challenge. IPCC AR5. Image credit, NOAA Climate Program Office. Measuring the pulse of the ocean. It's hard to measure how something is changing with only a couple of data points. How can you tell what is normal? By maintaining networks of ocean observing systems in each ocean basin over multiple decades, we are checking the pulse for what is normal, and can detect when ocean conditions stray from that baseline. The Global Ocean Monitoring and Observing Program, GOMO, funds a variety of devices that measure ocean temperature, and other important ocean properties like salinity and carbon dioxide, in each of the planet's ocean basins. These long-term and widespread observations allow us to measure changes in ocean heat and better predict future climate impacts. Expendable bathythermographs, XBTs. We support the advancement of ocean science. GOMO provides support for institutions from around the country that foster advancements in understanding and protecting our global oceans. View the research projects that impact people, ecosystems, and the economy.